Okay, now we're going to use the little literal equations to actually solve some problems. So in example 2, we have in a half hour, Sarah is meeting her friends at the lake 6 miles from her house. At what average speed must she ride her bike to get there on time? So this is going to involve the distance formula. We've seen this a little bit so far. Definitely in class, we've had questions about it. So some of you guys may have talked with me a little bit more about it than others. But our distance formula is distance is equal to the rate times the time. So in this example, we know the distance. We know that she's riding her bike, or she's riding her bike 6 miles from her house to get to the lake. So we know that our distance is equal to 6 miles. In a half hour, this is when it's happening. So they're giving us the time right there. So when we use our distance formula, we do want our time in hours. So a half hour is 30 minutes, but how much of an hour is that? That is 1/2 of an hour, or you also could use 0.5. That is a terminating decimal. I am okay with a 0.5 or a 1/2, your preference. So now let's just plug into, oh, last thing. They're asking for what is the average speed. So that is going to be your rate. We're going to get an answer in miles per hour because our distance is in miles, our time is in hours, and so the rate is miles per hour. So if we just plug into our formula, distance equals rate times time. Like we said, we know the distance is 6, so I'm plugging in a 6 for the D. We don't know the rate, but we know it's being multiplied by the time, which is 0.5. And now we just have to solve for the rate. The rate is being multiplied by a 0.5, so we can undo that by dividing by a 0.5 on both sides. And our rate is going to be equal to, one thing to think about, I find sometimes students get a little confused on dividing with decimals just because we're not thinking about what's actually happening. So if we have 6 and we're dividing by a 0.5, that's not the same thing as 6 divided by 2 to get 3. The question is 0.5, how many 0.5s fit into 6? It's actually going to be a bigger number. It's going to be bigger than 6 because you can fit a lot of 0.5s in there. So 6 divided by 0.5 does give us 12. That's why we got a bigger number because 12 0.5s will actually fit into 6. This is going to get a label, miles, miles per hour. So the rate, what average speed must she bike to get there on time? She needs to go at 12 miles per hour. Okay, so we have another question with Sarah again. This time she's going to go to the store. It's 2.5 miles away. She has only 15 minutes to get there before they close. At what average speed must she ride to get to the store before they close? So we just did an example very similar to this. They are asking for the average speed again, so that's the rate that we don't know. We're going to use our same formula, distance equals rate times time. So let's figure out what we do know. They gave us the distance 2.5 miles away. So our distance is 2.5 miles. They gave us the time. Now, time is 15 minutes. Again, that's in minutes, and we want this in hours. A couple ways to think about that. You could say, well, how many 15 minutes are in an hour? Some of you guys might know off the top of your head, oh, there's 4 of them. So my time is 1/4 or 0.25. If you're not sure, a quick way to get there is you can take your 15 minutes and put it over the total number of minutes in an hour, which is 60. And that's going to give you the fraction of an hour for the minutes that we're working with. So 15 divided by 60 does reduce to 1/4. You can use a 1/4 in the equation. That is a terminating decimal, so you may also use a 0.25. All right, let's set up our formula. We have distance equals rate times time. I'm going to fill in what we know. We know our distance is 2.5. We don't know the rate because that's what they asked us to find, the average speed. We're going to multiply that by the time, which is a 0.25. And if you write in just 0.25, that's the same thing. And now we're going to solve the equation. We want to solve for r. We can see it's being multiplied by a 0.25. Opposite of multiplication is division, so we're going to divide both sides by 0.25. 0.25 divided by 0.25 is 1. 1 times r is still just an r, that's why we get to cross those off. So our rate is equal to 2.5 divided by 0.25. So again, is this number going to get bigger or smaller than 2.5? How many 0.25s fit in? And so there's actually more than 2.5 of those that fit in. So if you type that into your calculator, you are going to get 10. So our rate is 10, and our label was in miles, and then we were in a unit of hours. So her speed, she has to ride her bike at 10 miles per hour to get there on time.